Sick of waiting for your CI tests to pass or having to manage different CI servers for different teams? Using BuildKite, you can run fast and reliable CI pipelines for every type of project, whether it's back-end tests, mobile apps, or even custom hardware. BuildKite's agent helps you scale to thousands of parallel jobs, and your secrets and source code never leave your infrastructure. There's great documentation, a clean web UI, and plugins for different types of tools. Visit BuildKite, that's KITE.com/Hanselman for a 14-day free trial and see how Shopify scaled from 300 to 1,500 engineers while keeping their build times under 5 minutes. That's BuildKite.com/Hanselman. Hi, this is Scott Hanselman. This is another episode of Hansel Minutes. Today I'm talking with Carol Nichols. She's the owner of the Integer 32 Consultancy, the author of the Rust programming language book with Steve Klavnick, as well as the wonderful Rust in Motion video series. How are you?
Great. Thank you for having me on.
So you're a Rust core contributor. What does that mean to be a core contributor?
I am part of the core team, which is the team that makes overarching decisions having to do with the project. So there's the compiler team and the language team do a lot of the technical work as far as evolving the language and maintaining the compiler. The core team is more of the, what is the direction of the project? What do we want to say as far as describing Rust evolution? How do we talk with production users? Things like that.
Is that something that one is like nominated for, or do you just kind of like sidle into that job? How does one become a core member? Is that like, because there's a lot of people who are listening who want to get involved in open source, and it's all that they can think about to like maybe fix a spelling error in the docs. How does one make themselves known and then work their way up to effectively what is leadership?
Yeah. So a lot of the core team members are leaders of some of the sub teams, and but not everyone. I kind of got invited by doing a whole bunch of work that no one else was doing, and that got noticed, and I got asked to join the core team. So in general, I think we're still trying to figure out how we want the project to be run. That's one of the things we're struggling with on the core team is how should the governance of this big open source project work? And so it's been pretty ad hoc, but in general, if you like the different teams that have different responsibilities usually have a meeting, mostly in chat, sometimes on video, to discuss the kinds of things that we want to work on together as a team. And often teams have smaller issues or ways people can help out, or you see people in the meeting saying, "Oh, I wish we had time to do this." And that's a great opportunity to jump in and get involved in things. And if you keep showing up and keep doing work, people will notice that because it's pretty rare, which I understand as like most people don't have very much time to spend on open source. So you get a PR in here, a PR in there. But if you have the time to dedicate to it, people will take notice. And the more work you do, the more work you'll get as you show yourself to be someone who enjoys and has time and is capable of doing what needs to be done to keep the project moving. And that's kind of how you get rewarded with leadership positions so far, from what I've seen.
It sounds like what I tell my kids is that it's like a big part of success is just showing up. But then, of course, figuring out how you can find the time to show up while also having a life is challenging. Everyone in open source has that issue.
Yeah.
Now, have you found the time to show up because this is something that you're using in your consultancy?
Yes, that's definitely something that motivated me to start my own company, is that I can choose to not be earning money and spend some time on open source. A lot of the team members are lucky enough to be employed by Mozilla, who employs most of the people who work full-time on Rust. There are some other companies who let people spend time on working on open source Rust stuff And that's another way that people get time to work on Rust things. But
Mm-hmm.
yeah, I'm very lucky to have a lot of savings, not need to work 100% of my time, so that I'm able to contribute to open source, because I think open source in general is really important, and I think Rust in particular is a worthwhile way to spend my time.
So Rust is a worthwhile way to spend your time. It's been around for 9 years, and some people have said it smells like, or it is syntactically similar to C++. Why was C++ lacking, and why did someone at Mozilla need to make Rust? What was wrong with C++, and what does Rust try to solve?
So Rust is trying to solve memory safety problems. It's trying to be a replacement for both C and C++, and be memory safe across threads as well. Though I would say those are the big aspects of Rust that are different. The memory safety is achieved through this system of ownership that makes
Mm-hmm.
sure there's only one owner of a piece of data at a time, and that owner is responsible for cleaning up that data, which those cleanups are inserted by the compiler so that you aren't doing operations like alloc and free, which people mess up all the time.
Mm-hmm.
And those ownership rules extend across threads, and the type system of Rust helps enforce that. So where race conditions, data races are very easy to do in C++, and C++ is getting things like the shared pointers, smart pointers that do some of this logic, but Rust has it built into everything by default. So whereas you have to upgrade your C++ to the newest version, then you have to choose to use the shared pointers. This is an abstraction that's the default to use in Rust. So I feel like the whole mental model is different, and the abstractions are built such that the default is both safe and fast to use.
When people are moving from C or C++ or whatever they learned in school, and then they enter the kind of the world, and they start using Go or Java or .NET, and they think that there's two choices of how one does memory. There's like a slider bar, and slider bars are supposed to have like multiple stops. They're supposed to slide, but people
Mm-hmm.
think that the slider bar has two choices, which makes it effectively a slider bar that's a checkbox, where it's like, well, either allocate your own memory or have a really sophisticated garbage collector, and there's
Mm-hmm.
nothing in between. It seems like Rust tries to find a better compromise.
Yeah, we're trying to break the slider into pieces and be off the slider. A lot of Rust choices we talk about taking trade-offs that seem like they have to be one or the other, and saying, what if it doesn't? What if we can have both? And it's been amazing to watch it evolve, and get to use this language that defies these expectations and makes these trade-offs moot.
So when I was doing C and embedded systems work, I allocate my own memory. And if I was a mediocre programmer, which I am, somewhere else, I would go and free it, and then you'd leak memory, or you had a whole class of things. You'd have
Yeah.
null pointers and dangly pointers. And
Mm-hmm.
then in the Go Java .NET world, it's like, well, let's make someone who's in charge of cleanup, like a janitor, which
Mm-hmm.
is like, I'm sloppy, so we'll have a sloppy system cleanup. When you said a system of ownership, what does that mean?
So it's kind of like if you, this is a metaphor we use in our video series. Instead of like having a janitor walking around the party all the time asking, "Are you done with that? Are you done with that? Are you done with that? Can I clean this up?" It's more like if you bring your covered dish to the potluck, and you're responsible for washing the dish that you brought and cleaning up what you brought, and you can let other people use the food you brought and the plates you brought. But at the end of the night, it doesn't matter who used it. You're the owner, and you're responsible for cleaning it up. And no one else is going to do it for you. So you don't have to worry about washing something twice. Once you clean it up, no one else can use it. You're going to take it home, and no one's going to expect it to still be there. So I hope that metaphor helps clear things up a little bit.
No, let's dig into that a little bit.
Okay.
So in the garbage collection world, it's just like chaos. It's like, woohoo, I'm just making memory. And I worry, someone
Mm-hmm.
else who is not me. We always talk about single responsibility principle when we design our large systems, but no one ever wants to be responsible for their own memory. And people are just making lists and passing things around by reference, and everything's fine. And someone will figure it out. And until, Gen 1 or Gen 2 or Gen 3 of the garbage collector pauses everything while we stop and the janitor cleans up after the party, and then we're allowed to continue dancing. You're saying that with Rust, the compromise is you are in fact responsible, but it is you and you alone who are responsible for your things, no one else.
Yes. And the compiler is taking care of this. So, and it uses when the owner goes out of scope, which is kind of like when you decide you're going to leave the party. That's when that cleanup happens. So the compiler can see you're going out of scope. This variable is going out of scope, and this memory can be cleaned up now. And the compiler is going to check that no one else is currently using that memory. And if you've written your code in that way, it's going to refuse to compile. And so these checks happen when you compile your code. It inserts these statements to clean up exactly where it knows that it's safe and correct to clean up. And there's nothing happening, no determination of when that happens at runtime running alongside your code.
Now that's very interesting. So for people who are listening, take a moment and absorb that, because a garbage collector at runtime determines that someone's going to get and leave the party, but Rust has figured that out ahead of time and it's baked in. So scope exiting happens, and it's almost like an aspect-oriented programming where it looks at the code and it injects in what would have been your manual free and does it for you.
Yeah. It's similar to the concept of RAII in C++, which is resource
acquisition is initialization.
That one. Yes. It's a terrible acronym because to me it's more about cleaning up, not the acquisition. That's
well,
important.
It seems like when we were talking about RAII, resource acquisition is initialization, in the late 80s, it was about accessing resources where memory wasn't a resource, but maybe a port was a resource or a file handle was a resource. You're expanding that concept to memory itself being a resource in that sense. And then do you include reference counting as well, or you do not?
There is a reference counted type that you can choose to use, and it works in an interesting way where it's considered a smart pointer, and when the last that lets you kind of have multiple owners, and when the last one goes out of scope and the reference count is 0, then it gets cleaned up. So it still kind of fits into this idea of scope and something special happening when something goes out of scope, but you can opt into doing reference counting.
Hey friends, Backlog is an all-in-one project and code management tool development teams have been waiting for. With project management, bug tracking, wikis, and Git rolled into one easy-to-use platform, Backlog provides the powerful features that development teams need under a clean UI that anyone can use. You can easily onboard your whole team and start working on tasks in minutes. Additional features like Gantt and burn-down charts make it easy to manage projects. Mobile apps keep your team connected, and simple pricing scales with you so you can stop worrying about per-user charges. Build your next project with Backlog. Get a 30-day obligation-free trial at backlog.com/HanselMinutes. That's backlog.com/HanselMinutes. There was an interesting tweet earlier yesterday by Yehuda Katz, who said there was been a little bit of a low-key controversy going on Twitter, because there's always a low-key controversy going on, where people have said, Rust got nothing done in 2019, and Rust is boring. And I love that even on the Rust homepage, there's actually a wonderful quote from Chris Dickinson from NPM that says, "My biggest compliment to Rust is that it's boring." And that's an amazing compliment. And then Yehuda says, Rust does something that everyone said was impossible when I started programming, being able to write tens of thousands of lines of safe code without the performance costs incurred by garbage collection. Do you agree with that?
Absolutely. I think I retweeted it. Stepping back and thinking about that is really uplifting, I guess. Mm-hmm. When you're in the day-to-day of working on something like this, it's hard to kind of step back and remember that you're doing something useful. And I really think I've had the opportunity lately to do a few talks about how I think Rust is moving the industry forward, because these memory safety problems have just caused so many problems. And you said you were a mediocre programmer before, as many of us are, myself included. But even the best C programmers, even the people who have learned every single rule that about undefined behavior, and even people at NASA who code review every line for an hour, even those people make these mistakes in C and C++ that lead to these memory safety problems. And we've known that this happens for years and years and years. I think someone from the Microsoft security team did like a survey of all the Windows security problems, and 70% of them over the last 12 years were the root cause was memory safety problems. So like we keep doing the same thing over and over again. And I really feel like Rust is changing that, is trying to stop making that mistake over and over again, and so that we can make some new mistakes instead. So I really feel like it's moving us forward. I'm really honored to be working on it and be a part of it.
When we think about how in the 80s and when people started really getting into C++ and thinking about these problems, and then 10 years ago when Rust, or 9 years ago when Rust was introduced, but it still hasn't taken over the world. I mean, there's a lot of enthusiasm around it, but people still write C++. Why isn't this a slam dunk? Why isn't this a viral concept that's taken over the planet, and we've rewritten Windows and all complicated systems in Rust?
Well, the code that's existing, it is existing and doing what it needs to do, and there's a lot of legacy code out there, and I'm very sympathetic to, if it's not broken, don't fix it. So the places that we're trying to get Rust adopted are the places that are still using C and C++, which is already kind of a legacy decision. And those places are generally large enterprises that are very risk averse and slow to move on anything. So I'm not at all surprised that despite the enthusiasm for Rust, our adoption has been slow. And I think we're happy to be around and be ready for the slow adoption, because the types of people we are trying to get to use Rust are not the type to make a quick decision.
You're right. This is not something that you just jump into.
No.
Has there been talk of making the on-ramp or the bridge between C and C++ to Rust more easy? Is it naive of me to think that if there were a converter?
There are converters.
Okay.
There's one called C to Rust that Galois has contributed to the open source community. There's BindGen. I'm never quite sure how to say it, but something that generates bindings in Rust to, I'm not sure which way it goes. Either in Rust to C++ or in C++ to Rust. I think it's tough when you have a lot of function overloading in C++, because Rust doesn't have overloading. I think that gets tricky. But I have a talk where I took a C library called Zapfli. It's a compression tool, and I rewrote it. It's written in C. I rewrote it to Rust using the foreign function interface to do one function at a time. And I kept the test passing at every commit, which I think proves that you can do like an incremental rewrite by using this FFI. And you don't even have to finish. You could stop at any point when you've gotten enough value from the rewrite. You could start with the parts that change the most. You could start with the parts that are the root cause of the most bugs, parts that crash the most. And if you get what you're looking to get out of the rewrite, then there's more important things that come up, you could stop if you do this in an incremental sort of way.
Right. And then in the C world, there's things like, libc for single-threaded programs and libcmt for multi-threaded programs. Rust is known for like highly concurrent systems. Was that like a fundamental tenet of the thing? Like, well, we're doing this, let's make sure it works when there's a lot of threads doing a lot of stuff.
Yeah, that was one of the main goals. The reason that Mozilla is so invested in it is that they're slowly rewriting Firefox in Rust. And Firefox is a mostly C++ program that its purpose is to run untrusted code from the internet. So they're very interested in closing any security holes, and they're also interested in improving performance by parallelizing everything that they can. And they have tried to parallelize stuff in C++ and found that it just increased the memory safety problems they had. So when Rust evolved out of Mozilla Research, then they created Servo, which is an experimental browser written entirely in Rust. And now they are pulling components out of Servo and into Firefox. And the Firefox Quantum release that happened, I think, a year or two ago.
I remember.
One of the big parts of Quantum that improved the performance was the CSS rendering from Servo that was written in Rust and pulled over. So that parallelizes the entire rendering of the CSS on the page.
And I remember when I went to Quantum as a user, it was the same Firefox that I felt good about. It ran just as well. So nothing dramatic happened, which presumably was the right idea.
Yes, yeah.
Not noticing was success.
Yes. Hopefully noticing that it was a little faster, but not noticing
Indeed.
that anything is broken.
Well, and in a world where the processors have so many more native processors, native cores, and the ability to do, hyper-threading and things like that, we're going to want concurrency baked into our languages.
Yeah.
So if I understand correctly, in there's operating system threads, Linux has native threads, Windows has a native notion of threads. And then programming languages have this idea of a thing called green threads, which is not an operating system construct. It's just their own vibe on what green threads are. But since Rust is kind of a lowish level language, the Rust standard library provides us support for threads. So when you say thread spawn, it's real. It's low level. You're telling the operating system to spawn a thread. What kind of problems go wrong when you do that in C and C++, where you just make threads, put data on the thread, and start going to town that Rust solves?
So I haven't actually done a whole lot of C and C++ programming myself because I am not capable of doing anything safely.
Well, that's actually kind of cool, actually, if I may, because then you're saying that you've been doing Rust for so long that this has freed you from that kind of administrivia, which is the whole point of the language.
Yeah. From what I understand, it's that you can just kind of pass pointers back and forth across threads, and you have to keep track of who's cleaning that up or who's accessing that when and who's modifying the data that it's being pointed to, and if that pointer is still valid. And all of this is enforced by the Rust type system such that you can kind of mark particular data structures as, okay, we can share this between threads because it's synchronized, access to it is synchronized, or we can move ownership of this piece of data from one thread to another, and then you're no longer allowed to access it in the original thread. So the system of ownership ties into the multi-threaded programming in Rust.
That is really interesting because even C is somewhat, I wouldn't say threatening, but intimidating to me. And multi-threaded C or C++ is just oh my goodness, I don't want to have to go back and get my PhD.
Yes, but I definitely feel like the Rust compiler is it's like a pair programmer that is helping me to get everything right that you have to manage yourself in C and C++. And I don't have the brain power for that. I'm more interested in whatever problem I'm trying to solve. I don't want to have to think about, okay, is this pointer still valid or not? Or is this over here? Or who's responsible for this? Did I clean that up? I don't want to have to think about that. Computers are really good at taking care of all this trivia, all this administration, and making sure you get it right every single time. Computers can do that. So that's what I feel like Rust is doing for me.
Well, and here we are 40, 50 years past C and C++. And I know that there's probably a lot of people who will email me and say that I program in C and C++ every day. But think about how far computers have come in the last 50 years, and we're still thinking about this stuff. Shouldn't our language do it for us? And I love that, I'm kind of bumbling around and asking these questions, and I don't know if they're good or not. And you're like, well, I don't really know because I'm a Rust programmer. I don't think about those things. I know about threads and I think about threads, but worrying about hurting myself with a thread is
Yeah, it's not something
beyond
to
my
worry about.
space. That's a really a testament to the language itself. So this idea of ownership goes cross threads, and then you said that you can do both moving and borrowing. So this idea of ownership can't be broken. You have to be specific which thread owns a piece of data.
Exactly.
Interesting. I saw that there was an article, or I'm not sure it was a book that was called Fearless Concurrency in Rust. Is there a sense of you don't have things that you have to worry about? You can move without fear when you're coding in Rust.
Definitely. Um, it's again, I don't have a whole lot of experience with C and C++, but I remember in Ruby, the story is kind of similar that there's not a whole lot of support for writing concurrent stuff in Ruby. And I would use concurrent libraries in Ruby and they would crash a lot and do weird things. And that
Mm-hmm.
kind of scared me off from trying to write it myself. But yeah, I don't feel that way in Rust. And it's definitely, I've heard from other companies that, hire people who are more junior who, if they were writing C and C++, you'd want to review their code a whole lot to make sure it was right. But
Mm-hmm.
the compiler is doing that review in Rust. So if the code compiles, you've already have that code review basically, and you can look more at the logic rather than the pointers and passing data around between threads.
Well, that brings up a really interesting question, and I appreciate that you've had me think about this. Is that if I'm going to go and hire someone in their mid-20s, this is someone who may have never been exposed to C or C++ or thought about any of these problems. So, how would you test them for their understanding of concurrency without accidentally testing or quizzing them on the historical context of languages or dead or otherwise that they would have never have used? Like, I want them to understand how threads work and how to move data around. But to your point, they may have never done that work. So should they have studied, Latin when I'm asking them to speak English?
Well, so I think this is a really interesting question. There's still things that are possible in Rust. It's still possible to create deadlocks. It's still
Okay.
possible to have resource starvation.
Mm-hmm.
It's still possible to be holding on to a lock longer than you think you're holding on to it.
Mm-hmm.
It's just that the memory safety part uh, is solved for you. So I think there's still, you still have to think about, how am I going to parallelize this problem? Like where is this where can we do things that are separate, that are independent? Where do we need to synchronize the data together? Where can we spawn something and check on it to come back? So I think more of the concepts of how you do the work in a concurrent or parallel fashion is still definitely relevant. But it's less of is this undefined behavior or not? Or is it possible that this thread ends before this other thread and you don't think it's
Mm-hmm.
possible and it actually blows everything up?
That's really helpful to think about. Yeah, it does. Because as someone who is of a certain age, I don't want to say to a new person that I'm going to hire or to my children, you need to learn how to change your own oil and how to, double clutch a stick shift in a world where lifts exist.
Mm-hmm.
You don't need to disassemble a carburetor. I don't want to accidentally ask someone how to disassemble a carburetor if that's just simply not a thing anymore. But I would like them to have a general sense of how cars move in the world.
Yeah.
So applying that analogy to programming languages, I think, is a fair one.
Yeah. And I'm not of the school, obviously, since I don't know C intimately. I'm not of the
Mm-hmm.
school that says, oh, to be a good software programmer, you have to know C. Because for one thing, then why don't you have to learn assembly? Which I had a little assembly in college. I understand the concept of assembly.
Sure.
You
You
should
just
not be
don't.
programming in assembly on a day-to-day basis unless your work is at that level. It's completely possible to do meaningful work at a higher level in computer programming. We have come that far that you are able to do that. It is not required for you to know what every bit of the computer is doing at any point. And it's not actually possible for anyone to hold that in your head anymore. Computers are doing too much. The processors are rearranging your instructions in ways that no one even understands much anymore.
Exactly.
So yes, I definitely think there are concepts that transcend, and concepts like how do we split up this work that are higher level concepts that you should understand. And there are times when you'll need to dive into deeper things to figure out why something isn't working or why it's slow or things like that. But generally, like we made these abstractions, we should use them.
Exactly. I appreciate that. And if you go to rust-lang.org, you can learn how Rust can set you up for success even on embedded systems or low resource devices, on networking systems. It'll even compile to WebAssembly. It's a very welcoming community, and it appears to be really a language for everybody.
That's what we're trying to do.
I appreciate that. And folks can check out your book from No Starch Press. We'll make sure we include a link in the show notes, The Rust Programming Language with Steve Klabnik and yourself, Carol Nichols. And of course, your Rust in Motion videos available at Manning. We'll put that in the show notes as well. Thank you so much, Carol Nichols, for chatting with me today.
Thank you for chatting with me.
This has been another episode of Hansel Minutes, and we'll see you again next week.